Good morning, and thank you for joining this session on advances in Earth observation and analytics technologies and their deployment in forest and climate solutions globally. My name is Tara O'Shea, and I lead forest and land use programs at Planet. For those who are not familiar with Planet, I actually tend to introduce us by saying that we have a bit of a mantra, and that is that you can't fix what you can't see, or you can't manage what you can't measure. This is something that we hear over and over, and it's something that we think is really at the root of many of our global sustainability and climate challenges. So it's this piece of the puzzle that we are trying to help solve through space technologies. Planet's mission is to image the full Earth every day in order to make global change visible, accessible, and actionable. So how do we do this? How do you go about imaging the full Earth every day? Well, Planet has actually deployed the largest constellation of Earth observing satellites in human history, but most of these satellites are really quite small. So what you see here is an illustration of our Dove constellation. This is a constellation of over 100 small satellites that together image the full Earth every day at about 3.5 meters per pixel. This is complemented with our SkySat constellation. This is a constellation of very high resolution tasking satellites. So you can tell them where to look and they can image anywhere on Earth multiple times a day at 50 centimeters resolution. So you can see here, these satellites and the information feeds that they're creating, they not only complement each other very well, but also together, they create a truly unprecedented Earth observation capacity, where for the first time, we have information on the Earth at the pace and scale at which change occurs. Today, Planet owns and operates 3 constellations of satellites in space. Our Rapid Eye constellation was actually decommissioned about a year ago, but it offers a rich 5-meter archive dating back to 2008. Our Dove constellation, as I mentioned, this has over 100 small satellites in orbit, imaging the full Earth every day at about 3.5 meters per pixel. This is in 4 and soon to be 8 spectral bands. And then the SkySat constellation, this is the largest sub-meter monitoring system in space today, with the ability to image at 50 centimeters any place on Earth multiple times a day. So, we could kind of spend the rest of the time on this talk just talking about satellites in space. I know that that's really interesting, but I do want to transition to, why is it that we're putting all of this hardware into space? And it's to create, a new sort of Earth observation data product that gives us much more actionable insights on change. So I tend to think of Planet's data products really in 4 categories. The first is Planet monitoring. And so this is that daily information subscription feed where you can subscribe to anywhere on Earth, monitor daily, and download the imagery that's most relevant to your own questions or challenges. The second category of data product is Planet base maps, or many in the industry might call this a mosaic. And this is really great for broad area monitoring. So you could say, I want to see the whole state of California every month. And we would stitch together the best, most cloud-free pixels over that area and time period, stitch them together, and provide you with an analysis-ready base layer to use in your analyses or in your applications. The third category is Planet tasking. So I mentioned our SkySat constellation. This is the ability to task a very high resolution satellite anywhere on Earth and monitor it at 50 centimeters per pixel. And lastly is what we call Planet analytic feeds. These are the automatic extraction of insights from the satellite imagery itself. So today we have these feeds available on buildings, roads, ships, and planes. You'll also remember I said in our mission, a key part of what we're doing is to make this data accessible. That's really important, and that's a task that we take very seriously. And so we invest a lot into ease of delivery options. Planet is an API-first company so that you can bring these new Earth observation data sets directly into your operational workflows where decisions are made today. Many of you might also be familiar with Planet Explorer. This is our web-based GUI. It's a really easy and intuitive way to explore and interact with the daily information coming down from Planet's satellites from space every day. And lastly, we also provide web tile delivery, or WMTS. So this is what you see often in the backdrop of, for example, web or mapping applications. This allows you to bring these higher spatial and temporal resolution data sets directly into those applications that you're building on the web. So now that we have a bit of an idea about the satellites, the information that they are creating and how those are delivered, what I'm really excited to focus on today is the applications that we are seeing from our global customer and user base in forest and climate applications around the world. So, in forest monitoring and measurement, we've actually been quite fortunate that satellite information has been informing these systems for decades, dating back to NASA's Landsat mission in the 1970s. So what you see here is a Landsat image over Brazil. This is about 30 meters per pixel with a revisit every couple of weeks. Here is an image, this is a PlanetScope image over that same area. So you can see in terms of spatial resolution, it's about 100 times the resolution at about 3 meters per pixel. And it's also a daily revisit. So suddenly you have sort of very actionable information that reflects the pace and the scale at which change is occurring. Those white lines that you see here, those are actually property boundaries, right? So suddenly this information is much more actionable in terms of we can understand where that change occurred and perhaps a better understanding of why and what to do about it. So there are a few aspects of these new technologies and data sets that I think make them particularly relevant to solving forest and climate challenges around the world. The first aspect is the global coverage. So the idea that we can have these higher resolutions in a wall-to-wall way. This is really, really critical, especially when you combine that with the temporal aspect of the daily revisit. So for the first time, we can have tree or stand level detail in a wall-to-wall way at high frequency. And then of course, as I mentioned, we also finally have this in a cloud-based format where it can integrate easily with our own operational workflows and decision-making processes. I just want to highlight, forestry is actually one of Planet's largest and fastest growing markets. And I think that's because there are such innovative leaders in this field that are prepared to take these technologies and create really critical and innovative solutions on the ground. So you can see here, a number of civil government agencies, commercial forest entities are taking this data today and applying it already to forest solutions globally. And it's a few of those examples that I would actually like to walk through during the rest of our time together. So this first example is from a forest in the Eastern Democratic Republic of the Congo. With the Food and Agriculture Organization of the United Nations, the DRC has actually started adopting Planet's higher spatial and temporal resolution information in its national forest monitoring system. So I want you to see sort of what that looks like and what sort of solutions that helps facilitate. This is the same area just a few months later. So you can see at this spatial resolution of PlanetScope, we can not only see outright deforestation events, but we can also see degradation, the removal of individual large tree crowns. We can see the roads that go in as precursors to that change. And then again, just a couple of months later, we actually can capture some of those areas of degradation beginning to green back over. And so I like to show this example because I think it really highlights some of those spatial temporal aspects of the data, and really demonstrating the things that it lets us capture. Because when we see this, we understand that the monitoring systems that we've been using traditionally at lower resolutions, at an annual cadence, we're really missing some of these dynamics of change, and critically missing the carbon implications for what this means. Another example that I wanted to highlight that is unfortunately increasingly all too common with the changing climate is the relevance of this information to wildfire, both preparedness and response. So this is an example from those awful fires in Australia just a couple of years ago. This is in New South Wales. At the end of 2019, when this was happening, actually all 3 eastern seaboard states in Australia were using planet imagery before, during, and after these wildfire events. And this was not only to inform response operations, but also to understand damage assessments, both to forestry, again, at that stand level detail, to forestry resources, as well as to the built environment. Increasingly, we're seeing this data not only inform these sorts of response operations, but also risk mapping and mitigation. And I'll come back to that in a little bit. Another example, this is from a customer in the Czech Republic, their Forestry Management Institute. I'd like to highlight this example as well because it is, again, another, unfortunately, all too common use case across many geographies as climate change expands the habitat for the bark beetle. So bark beetle kills an unprecedented number of trees. Forest managers in many geographies need to be able to quickly identify impacted dead forest stands so that they can remove trees to mitigate the spread. And what's really interesting about what the Czech Republic did here was they actually used Planet's high spatial and temporal resolution information to do that early identification and intervention on dead tree stands. So you can see here the image on the right where infected tree stands are really quite easy to tell. And another thing I really like to highlight about this example, because I think it's so innovative what this customer did, was they combined the PlanetScope information with Sentinel-1 data, which of course has additional spectral bands. And so it was the combination of this rich spectral information from the Sentinel mission with the spatial and temporal monitoring and intervention capabilities of the Planet data to create these sort of derivative products about where risk was and where action needed to be taken. So suddenly forest managers across the entire country are now operating off of a single and improved set of information. So in addition to some of these applications where Planet's data is being used to inform improved forest management or monitoring systems, I also wanted to highlight some of the sort of next generation analytics that we are seeing in the forest and climate space. And often what I want to highlight in particular, what we're often seeing is a combination of Planet's high resolution space-based monitoring with LiDAR data over forests in particular. So for those who are not familiar, LiDAR, or light detection and ranging, this is a laser sensor. It is the same sensor that self-driving cars use. So it measures distance. And when you fly a plane with a LiDAR sensor over a forest, you get back this really nice 3D or volumetric picture of the forest. And this is really great because in ecology, volume is biomass, which corresponds to carbon. And so we have, where you're able to fly these planes, you have these sort of really rich volumetric maps of the forest, and that can help you understand where are the carbon stocks, where are there buildups of biomass. This is relevant not only to forest and carbon accounting systems, but also, for example, it's super relevant to things like wildfire risk mapping. And so in recent years, you know, the science has really advanced in terms of using LiDAR imaging for these applications. But as you can imagine, it's pretty expensive to fly a plane with this expensive sensor. And so we really only have this information over certain areas at certain points in time. But what many of our customers and many of our scientific users in particular have started to wonder is, what if you could extract those same volumetric insights from a passive optical space a sensor coming down from space? So in a much less expensive way, if you could extract those same insights over space and time. And that's exactly what many of our users and customers are starting to do. So essentially, they are using machine learning to correlate the volumetric structure of the LiDAR data to the spatial structure of the high resolution planet data. If you think back to that first example that I showed, the image of the forest over the DRC, you know, I tend to say that if you look at forest and planet data, it looks like broccoli, right? You can kind of see that spatial structure of the forest. And it is that spatial structure that the machine learning model is correlating to the 3D structure of the LiDAR data. And once that correlation is set, you can feed the planet data, just coming down from space everywhere, every day in a relatively inexpensive way, through that model and get those same volumetric insights across space and time. One of the first institutions to really pioneer this approach is the Center for Global Discovery and Conservation Science at Arizona State University. And they have actually successfully created and run these sorts of forest carbon models at a national scale at high cadence across all of Peru. They've now generated, I believe, 3 or 4 peer-reviewed publications on those methods and results. And so you can go ahead and look those up to learn more about how they are extracting these sorts of volumetric insights on biomass and carbon directly from planet data. And so just to illustrate, you know, what this might mean, you know, I like to think about, what if we could not only see deforestation occurring, but what if you also knew in an automated and cost-effective way what that meant in terms of carbon emissions to the atmosphere? You know, might this be the sort of practical and cost-effective tool that would help us better account for the real costs of deforestation in our decisions and for the real value of more sustainable land use practices? These are the sorts of derivative insights and the sort of potential that we see for this combination of Earth observation and analytics technologies. I wanted to give one more example that we're seeing from this sort of LiDAR and planet integration. I mentioned earlier, you know, our planet's data has done a lot of great things in disaster response, all sorts of disasters, including wildfires. And that's often because you do have the before and after shot at those high spatial resolutions. But increasingly, one thing that I think is really exciting is where we are increasingly seeing this information applied not only to disaster response, but also to disaster preparedness. And this is an example where it's being used to better understand and intervene on wildfire risks. This is an example specifically from California. So again, the California Forest Observatory, this is a partnership with Salo Sciences, Vibrant Planet, and the Gordon and Betty Moore Foundation. It's a really similar approach to what we just discussed. So training a machine learning model based on airborne LiDAR to then extract those same volumetric insights from planet's high spatial and temporal resolution information that is, of course, covering the full state at high frequency. So when it comes to wildfire risk mapping, the pieces of that, the sort of aspects of that LiDAR information, of that volumetric information that's really critical to understand is sort of the biomass or the volume of the trees themselves. So it's really critical to extract information on tree height, tree crown or tree cover, as well as the ladder fuels underneath. So this is a planet image in California around what we call the Wildland urban interface, or the WUI. And this is where, you know, we want to understand best where are there wildfire risks at play, where might you know, this sort of wildland urban interface result in the loss of life or property. And so you can see here, again, in the planet data, we have sort of that broccoli effect where you can see individual stand level details. This was sort of the state of the art. This is at 30-meter resolution. Again, remember we saw some of that imagery. This is what our best understanding of biomass at that scale would be. This is the result when you feed that trained machine learning model with the planet data. So you can see here we have a much better understanding of where there are buildups of biomass, where are those tree height, crowns, and ladder fuels creating sort of the most tinder should a fire event spark. What's really exciting about this project as well is that that sort of derivative biomass layer, again, the volumetric output of that model powered by Planet, that is then one data layer that is input to this wildfire risk mapping tool. So they actually combine this biomass information with information such as weather, wind, all sorts of other parameters, and they've put this into a single platform. You can check this out yourself at forestobservatory.com. But again, much like what we saw in the Czech Republic, the idea is that we can suddenly have all sorts of different stakeholders across a large geographic area operating from the same set of improved information. So with that, I want to invite you all to please stay and participate in the Q&A. Thank you so much for your participation in this session again. For more information, please do check out our various websites and social media channels. And again, please feel free to reach out to me with any questions, especially on the topic at hand today, which is forests and climate research. Thank you.
Hi, Tara.
Hi there. Hi, Jonathan.
Hi, pleased to meet you. Thank you so much for bringing Planet and your presentation to GeoIgnite. I'm very excited to have the talk with us.
Yes, no, thank you for having us. And yeah, thank you to the event organizers and all of the participants for joining.
Great. Let's, I wanted to start with a question. So folks, the Q&A is open. We've got time for questions for Tara and Planet. I'm going to take advantage of the opportunity to ask a question. So you're obviously, this talk and your focus is forestry. So is that the largest consumer group using your data? Is it the forestry sector, or are there other markets consuming the data, and or is it really forestry is the thing?
No, there are many markets using our data. So I think especially because of Planet's spatial and temporal resolution, so imaging everywhere every day at about 3.5 meters per pixel, there are lots of applications across several markets and several verticals. So forestry is a large market and a quickly growing market for Planet. But we also have hundreds of customers across other markets, including agriculture, civil government, mapping, and all sorts of applications.
Fantastic. Thank you very much. Okay, looks like we've got some action in the Q&A. So let's start at the top. What does volumetric forest data refer to exactly?
Yeah, that's a really great question. So volumetric analyses in forestry is really important because if you have the volume of forest, you have biomass. And it means you also have a measurement of carbon, as trees are essentially made up of carbon. So that is really critical to a number of applications. For example, in commercial forestry, it is a term known as inventory. So you know how much timber you have to harvest. Again, in thinking about deforestation, which a lot of people don't realize is, causing over 20% of global greenhouse gas emissions. And that's because every time we burn and clear these forests, all of that stored carbon is released into the atmosphere as CO2. And so the ability to directly measure the emissions from a deforestation event really represents a leap and bound ahead of how we've been doing this today, which is essentially to use sort of flat 2D imaging of satellite imagery to estimate a change in forest area. And then you multiply that by inventory data that someone actually measured on the ground with a tape measure for a tree in that area. So the idea that we could directly measure volume from space rather than having to do that indirect multiplication is a huge advance in terms of measurement, reporting, and verification. And then again, it also has lots of applications in commercial forestry and wildfire risk mapping as well.
Excellent, thank you. I'm going to close that question. There's a question from Jake. Can you talk more about carbon resource cost analysis you mentioned? It seems incredibly promising for putting a price on carbon.
Yeah, I think that's exactly right. And it's because of, what I just mentioned, this sort of leapfrog in our ability to measure forest carbon. And I think, arguably you could look at sort of the inefficiencies that have traditionally been associated with sort of measurement, reporting, and verification of forest carbon crediting as sort of a barrier to investment, right? And so I think you actually are now seeing many even commercial startups start to adopt these techniques. There are several, for example, like Pachama or like Salo that I mentioned, where they are going to bring these sort of automated approaches to carbon crediting to the market. And as a result, I think you're going to see the development of much more carbon projects, as well as a much more faith in the measurement systems for those who purchase carbon credits and those who provide performance-based payments for those reduced emissions.
Good stuff. All right, moving on to the next question from Blair. With your API, are there limits with how many requests can be made within a set period of time?
That's a great question. And I would actually recommend that you head over to developers.planet.com. I can put that into the chat if helpful, but there is a ton of documentation on our APIs as well as our product specifications. Because I don't know that I can answer that with specific correctness right now, but I will refer you to that developer center.
All right, here's one from Jeff Zeiss. Can one basically manage a forest, tracking growth, development of the canopy, identify different species and growth rates, track cutting, replanting, etc., with Planet data?
I would say that we do have users and customers doing each of those things. I want to be careful to clarify that some of those things might require additional data sets as well. So for example, we have commercial forestry customers that might have an aerial campaign over the timberlands that they're managing, let's say once a year with a hyperspectral sensor. That will allow them to do things like classify different species, but then they can use the Planet data to monitor those classifications over time, because again, you have wall-to-wall stand level detail coverage at a daily cadence. So in general, I would say yes, each of these use cases, with the exception of identifying tree species, although I have seen a few academic studies with folks doing really interesting stuff with Planet's 4-band data. But often, the data is used in combination with other data sets as well. I should mention that Planet's Dove constellation is moving from 4 to 8 spectral bands. And so we do expect even more use cases in forestry to come from that.
Excellent. All right, next question. How can Planet data be used to assist with reforestation?
That's a really good question, and there are a lot of people looking at that. So reforestation, obviously, it's a much longer process than, let's say, an act of deforestation, and it's also at a finer spatial scale. And so planet data is useful. It is used in this way. I'd say our SkySat constellation is particularly used in this way, and we do have a few partners beginning to assess the fit of SkySat for monitoring, plantations and reforestation projects. So it is extremely relevant, but I will say that reforestation is a slower process, and so it lines up a little differently in terms of the temporal resolution.
Thank you very much. From Fiona, how accurate is the extrapolation from LiDAR metrics to planet data?
Yeah, so most of the applications we have seen where these models are trained with airborne LiDAR, which tends to be, under a meter in resolution, the models are really quite accurate when then extrapolated to planet data. I would refer you, I mentioned that Arizona State University, their Center for Global Discovery and Conservation Science, they have really pioneered a lot of the peer-reviewed publications on this work. And so you can follow up with me, I'd be happy to send you some of those papers. Additionally, with the NASA JEDI data sets coming online, there are, especially in the academic world, those who are beginning to do those sorts of extrapolation with that coarser 20-meter LiDAR data as well. But with the airborne, it has been quite accurate.
Thank you. So we've got a question from David. Can Planet's technology be used to ascertain crop yield and health within the agricultural sector?
Yes, and I mentioned earlier that agriculture is one of our biggest markets, and it's really for this reason. So users can very well understand crop yield at a field level using the sub 5 meter data, and they can use that in combination with knowledge around, how those fields were treated versus how another field was treated. And so precision agriculture is actually a huge use case for our data and a big market demand for our sort of monitoring.
Okay, last question from Melody. Could you speak more about why combining different sources of geospatial data assists with understanding the forest?
Yeah, I think this is a really good question. And I think kind of with any application of remotely sensed information, there are kind of 3 parameters to the data sets. There's spatial, temporal, and spectral resolution. And each of those are able to measure different things. So, I think what Planet has really brought to the table is this improvement in spatial and temporal resolutions in a wall-to-wall way. And in terms of measuring forest resources, it's an unprecedented data set, truly, especially because, again, it's available for all forest ecosystems around the world. So that's really huge. But then to combine it with some of these other spectral bands, I think that's really powerful. So again, the examples with hyperspectral, where you can look at species identification, the examples with LiDAR, where you can understand volume and biomass. But what's unique is then you can always use the planet data to monitor those things that you have measured in the other spectral information in a very cost-effective way. So this idea that you can scale this sort of high resolution monitoring over space and time in a cost-effective way, I think is what's really kind of new and quite frankly, really applicable to a number of forest management challenges.
Great. Well, that concludes our time for Q&A. Tara, I want to thank you very much and Planet for being here and sharing your work. I think it was an exciting addition to the conference.
Thank you. And thank you to the GeoIgnite team. This conference has been great. Excited to be here.
Thank you.